Okay, for this problem, we have a converging lens with a 50 millimeter focal length lens. Must an object be placed where? Let's see, how far from a converging lens must an object be placed if its image is to be magnified 2 times and if it's a real image? And then also we can then try it for if we have a virtual image and it's magnified 2 times. Okay, so let's do part A. Where must the object be placed? So if its image is to be magnified 2 times. So if I go back to our cheat sheet and I look at some examples here, one of the ones that sticks out in this case is I want an image that's twice the size of my object. So I need an image that's bigger. So where do I place an object? Well, between 2f and f will give me an image that is bigger than my object. So that's for the second part where I need a virtual image twice the size of my object. I'm going to put it inside the focal length. So that's just a quick way to check to make sure. So we're expecting our object when we calculate it to be in between f and 2f. So in our case, we have our f is 50, so 2f is 100. So it's going to be somewhere between 50 and 100. So let's see how we can figure that out. So first thing is I'm going to think about my thin lens equation. So that's going to be 1 over d0 plus 1 over di is equal to 1 over f. And they don't give me any numbers for, they give me the focal length, but they don't give me numbers for d0 and di. But I do know that the magnification, I'll write this over here, the magnification is equal to a negative di over d0. And they tell me that that we want the image to be magnified twice. So I know then that m equals 2. So this is 2 is equal to a negative di over d0. So so that tells me that di is equal to a negative 2 d0. So I can plug that in. And I'm going to have, so I have 1 over d0. And so this, I also know it's going to be real and magnified 2 times. So that means this magnification is -2, because if it's real, then I know that it's on the other side of the lens. So I know I have something that looks like this. I have a converging lens like that. I already said I think it's between f and 2f, right? So let's just put it here. And and here's my f. When I draw this, I'm going to have something that looks like that. And so I already know that my image is going to be somewhere around here, and that informs me that I'm going to have a magnification of a negative. So this equation then becomes di is equal to 2 times d0. So I'm going to have plus 1 over 2 d0 is equal to 1 over f. Okay, so now what I can do is I'm just going to keep going here. So I'm going to have, I need a common denominator. So I'm going to use the common denominator of 2d0. In order to make this fraction have a denominator of 2d0, I need to multiply both the top and bottom by 2. So that's going to be 2 there, plus 1 is equal to 1 over f. So I can just flip this. This becomes 3. And now I can cross multiply. So I have 3f is equal to 2d0. And then so d0 then is 3 halves f. And when I plug that in, I have 3 halves times 50, which is just 150 over 2, or 75 millimeters. So that's my d0. And so you can see this is, if this is 50, then this is 100, then my my object distance is 75. So that makes sense. It works with our cheat sheet. And so what if the image is to be virtual? So what if for part B, what if it needs to be virtual and magnified 2 times? Well, all that does is it changes my magnification. So my magnification now is going to equal a positive value. So positive 2 is equal to negative di over d0. And that just means that then di is equal to a negative 2d0. So I just do the same thing again, and I can say, okay, I'm going to have 1 over d0 plus I forgot my negative. 1 over a negative 2d0 is equal to 1 over f. So this just says then 2d0, right? That's my common denominator. And I'm going to have a negative here. So I'm subtracting. So now I'm going to have 2 minus 1. So I still have to do the same thing to get the 2d0 for my common denominator. But now instead of adding, I'm subtracting 1 is equal to 1 over f. So that means 1 over 2d0 is equal to 1 over f. And so now d0 is equal to f over 2. So that means that d0 is going to equal 25 millimeters. And what does that look like? So if I can draw a little bit here, this is my lens, and here's my focal length. Right, so I'm going to put this right here. This is my object, and so what happens is I've got my ray comes in parallel to the optical axis, and I go through. I can go like this, and then go like this, and then last but not least, I have this ray. Notice they diverge on this side of the lens, so we project back. Oops, like that. I project this back. I project this back, and my image is going to be bigger, right? Something like that, and that's where I'm going to put it. This isn't exactly right, but it definitely shows me. Right, I didn't draw this very well, but it shows me that I'm going to have an image that's virtual, and it's definitely going to be bigger than my object. And if I were to actually do the ray tracing on graph paper, it would show me exactly that it was magnified 2 times, so it would be twice as tall.